We're about to start the really important part of this handout on operations with functions. We're going to start talking about composition of functions, and I really should have just gave it its own handout. This is a super important topic for you to be able to wrap your heads around. It's incredibly important in calculus. So there's a special operation with functions called composition that has no analogy with numbers. It's not like adding, subtracting, multiplying, or dividing. It's something else. When we form a composition of two functions, one function is followed by another. The output of the first function becomes the input of the second function. And here's an example that I hope is fairly straightforward. So suppose that the radius of a circle is a function of time in the following way. After t seconds, the radius is given by r of t equals 5t plus 1 centimeters. So I guess the idea is that as time goes by, the radius is growing, increasing, right? The size of the circle is growing, according to this formula. We already know that the area of any circle is a function of its radius. We know area is pi r squared, or we could think of a as a function name. So a of r is pi r squared. Is the area in square centimeters if r is measured in centimeters. So we can now form a composition of these two functions in order to describe area as a function of time. So area is a function of radius, but the radius is given by 5t plus 1. Area is a function of 5t plus 1, and that is really, this is just the formula pi r squared with 5t plus 1 written in the position of r. Let me just say a little bit more about this. So when I write a parentheses, I don't mean multiply. I mean it's like f of x notation, right? A of a box is pi times box squared. Normally we're putting the radius in here, but what we're going to put in is actually a function, r of t. A of r of t is pi times r of t squared. And so that r of t now, in this example, is 5t plus 1. A of 5t plus 1 is pi times 5t plus 1 squared. So that's what we mean by the area. If you want, you could just write a equals pi times 5t plus 1 squared. In this composition, if we plug in a value for time and evaluate the right-hand side, we get the area of the circle as a function of time. If the radius is increasing with time, the area is also increasing. Here are some examples with numbers, right? At time 1 second, the radius is 6 centimeters. I just plugged 1 into that 5t plus 1 formula. And then if the radius is 6 centimeters, pi r squared is 36 pi. At 2 seconds, here's the radius of the circle. Plug into the area formula. So here's the composition. First, time, that gives us the radius, and then the radius gives us the area. In general, we can often form a composition of one function followed by an f, followed by another function g. We can then give the composition its own name, say h, and we can write the following. We can write h of x is g of f of x. There's a lot of ofs there. Notice that we think of the composition as being performed inside to outside. So when we look at the order of things, like if we start with x and then go to f of x and then g of f of x, when you see that expression g of f of x, try to think that what's inside happened first. And, the output of f becomes the input of g. So there's this overlap where the range of f and the domain of g are the same. So there's going to be, we got to be careful not to just think in terms of x's and y's here, because what's a y for one function might be an x for another function, or when we work through the composition. Go to the next page. In some situations, we might apply the function g first, followed by f, which we would write as f of g of x. As you will see below, usually g of f of x and f of g of x are two totally different functions. If you change that order, you get something different. Sometimes they turn out to be the same. Before we start doing some problems, just a comment about notation. The composition is sometimes represented by a special little circle symbol. It's got nothing to do with degrees here at all. It's kind of like a multiplication dot, but it doesn't mean multiplication. It's a composition dot. And so if you ever see this f composed with FOG thing, I just always rewrite this right away as f of g of x. To me, this notation is much clearer. If I see g circle f of x, it's g of f of x. I just rewrite it that way right away. So I think I'm going to cut off this introduction video, and we're going to start the exercises in the next video.